Hi, Math 3 students. Today we are going to go ahead and go through some problems that are going to help us prepare for the SAT. All right. A lot of them are just reviews of different algebra topics that you've done before, mainly Math 1, some in Math 2. Kind of just some basic skills that are going to help you succeed on the assessment. So, the first question we have here is it says, put the equation of a line into slope-intercept form, simplifying all fractions. All right, so what is slope-intercept form? Slope-intercept form is a form of a line that is set as y equals mx plus b. The reason it's called slope-intercept form is the m represents your slope, and your B represents your intercept, all right? So essentially, to get a line into slope-intercept form, what your goal is to get the y by itself, all right? So looking at this problem, we just have to work to get y by itself here. So the only thing on the side with the y right now is the 5x. So we're going to subtract 5x on both sides. So we're going to say y equals negative 5x minus 4. Now, this guy is already in slope-intercept form, okay? And kind of some advantages of slope-intercept form would be that we can easily identify the slope of the line, which in this case would be negative 5, and we can easily identify the y-intercept, which in this case is negative 4. I want to throw one more in here because this one was kind of I don't know, I feel like this one was kind of easy, so I want to make sure we get some extra practice in here. Let's do 6x minus 3y equals, let's see, if we're dividing by that, we could do 18, all right? So something like this, if we want to get this into slope-intercept form, again, we have to work to get the y by itself. So what we would do here is first subtract 6 from both sides, or subtract 6x. So we're left with minus 3y equals negative 6x plus 1. Now, why do I put this x term in front of my constant? That's just helping put it in y equals mx plus b form. We like having that x term first. Then, to get the y by itself, we're going to divide both sides by negative 3. Okay? So we end up with y equals, and what you want to do is you want to divide each of these terms here by negative 3. You want to divide everything on the right-hand side there by negative 3. Negative 6 divided by negative 3 is going to be 2, so we end up with 2x. And then we have 1 divided by negative 3, which is going to give us a negative 1/3. All right, so that would be this equation in y equals mx plus b, or slope-intercept form. In this case, our slope would be 2, and our y-intercept would be negative 3. All right, so let's go ahead. We've got one more here. So we want to go ahead and try and get our y by itself. So if we're trying to get y by itself, what do you think would be our first step here? So what we want to do is get this 20x over to the other side. That would be our first step. So we get 4y equals negative 20x plus 8. Next, what we want to do is divide by 4. And again, you want to divide everything by 4. Okay? And when we do that, think about what we are going to get by it, or think about how this side of the equation is going to simplify, right? We should end up with negative 5x plus 2, because we do negative 20 divided by 4, which would give us a negative 5x. And then we get an 8 divided by 4, which is going to give us a 2. So in this case, our slope would be negative 5, and our y-intercept would be 2. All right. So the next thing we're going to go over is solving systems of equations. This is a super common topic on the SAT. So you want to make sure that you know how to solve systems of equations. All right. One of the ways you learn to solve systems of equations is by elimination. And elimination is when you put the two systems in the same form. Most commonly, you put them in what we call standard form, where it's like your x term, your y term equals your constant. These guys are all in what we would call standard form already, right? We have our x terms, our y terms, and then our constants. And what you want to do is you want to make it so that one of the terms cancels out. Now, sometimes the terms will cancel out right away, but other times you end up having to multiply either one or two of the equations by a number so that one of the variables cancels. So looking here, we actually already have a variable that's going to cancel. If we were to just combine like terms down the line here, 3x plus x is going to give us 4x, and 3y minus 3y, those cancel and they go away. And then 42 minus 22 is going to give us 20. All right. So when one of these variables cancels, it's going to make an equation with one variable remaining, which allows you to go ahead and actually solve. So we divide both sides by 4, and we get that x is 5. All right. So now we've solved for one variable. We know what one variable is equal to. So we can go ahead and take this x and plug it back in. Now, it doesn't matter if you plug it into the first equation or the second equation. Really, you can pick whichever one you want to plug into. I'm going to plug it into the first. So I'm going to do 3 times 5 plus 3y equals 42. So we get 15 plus 3y equals 42. So go ahead and see if you can solve for y now. Now it's just a simple one variable equation. So at this point, you want to do 42 minus 15. You want to subtract 15 from both sides. And you get 3y equals 27. Then you're going to divide both sides by 3, and you get that y is 9. All right. So our final answer here, typically you would write a solution to a system of equations as an ordered pair. So you could say 5, 9. All right, let's go ahead and try number 4. So here with number 4, unfortunately, neither of these cancel right off the bat, right? If we were to add these down right now, we would get 12x and negative 11y. Neither the x or the y canceled. So what we have to try and do is multiply one or both of the equations so that one of the variables cancels. There's multiple ways to do this. What I'm going to do is I am going to multiply this bottom equation by negative 2. And the reason I chose negative 2 is because when I distribute that, this negative 2 times 4x is going to give me a negative 8x, which will cancel with the 8x in the first equation. So I'm just going to rewrite my first equation down here. And then I'm going to distribute this negative 2 to everything in the equation. Now, a common mistake when people do this is they forget to distribute the number they multiply with to this side of the equation. Don't forget, you have to multiply everything. So we would get negative 8x plus 2y equals negative 12. So now, at this point, we can go ahead and just combine like terms. So go ahead and do that for me. Add down and see what you get. You should get negative 8y equals, and then we get 28 minus 12, which is 16. So we can go ahead and solve. We're going to divide both sides by negative 8, and we get that y is negative 2. So now we solved for one of our variables. To get our other variable, we're going to take our negative 2 and plug it into one of the original equations. It doesn't matter which one you plug it into. Let's go ahead. We'll just, again, plug it into my first one. All right. So we're going to do 8x minus 10 times negative 2 equals 28. We get 8x plus 20 equals 28. We're going to do minus 20, and we get 8x equals 8. You divide by 8, and we get that x equals 1. So our solution here would be written as 1 comma negative 2. So we're going to go ahead and solve another system of equations using the elimination method here. So in this case, they didn't line them up nicely for us, but we can line them up ourselves, right? So we've got negative 9x plus 2y equals 2. We've got negative 3x plus y equals negative 2. Now again, neither of these cancel right off the bat. I'm going to go ahead and multiply this bottom row here by a negative 2. And the reason I chose to do that is when I distribute this to my second equation, this term here is going to become a minus 2y, so it'll cancel with this term here. All right, so I'm going to go ahead and rewrite my minus 9x plus 2y equals 2. And then I'm going to go ahead and distribute this. Think about what you get when you distribute this negative 2. You should get positive 6x minus 2y equals positive 4. Then we can go ahead and add down, and we get a negative 3x. These cancel, and we get a 6. We can go ahead and solve, divide by 3 on both sides, and we get that x is negative 2. So at this point, I want you to go ahead, take your x value, and plug it into one of the original equations. Why don't we can plug it into this first one. All right, so plug it into the first one and see if you can solve for the y value. So when you go ahead and take your x value and plug it back in, we get negative 9 times negative 2 plus 2y equals 2. You get positive 18 plus 2y equals 2. We're going to subtract 18, and we get 2y equals negative 16. We can divide both sides by 2, and we get that y is negative 8. So our answer here could be written as negative 2, negative 8. All right. So let's see, number 6. So number 6 wants us to solve using a different method here, and the method is called substitution. Now, in order to use substitution, you have to have one of the variables completely isolated. And what that means is that you have to have it simply as y equals or x equals, so that you can take whatever it's equal to and sub it into the other equation. So in this case, we can see that this y is already isolated. So we can take what this y equals and plug it in here. So we get 3x minus 7, and then instead of y, we're going to replace y with what y is equal to, which is 2x minus 10 equals 37. So now at this point, we want to go ahead and distribute our negative 7. So we get 3x minus 14x plus 70 equals 37. So we're going to do 3x minus 14, which is going to give us negative 11x, plus 70 equals 37. And then we should do 37 minus 70. We get negative 11x equals negative 33. we divide by -11, and we get that x is 3. So now we've solved for one of the variables. I want you to go ahead, take what x is equal to, and plug it in to one of the original equations. So let's plug it into the first one, see what we get for y. So when we plug that in, we should get that y is equal to 2 times 3 minus 10. Y is equal to 6 minus 10, so y is equal to -4. So our final answer here is going to be 3, -4. All right. So now, another super common thing they'll ask you to do on the SAT is come up with an actual system of equations that represents a scenario. Okay? So, for number 7, it says, a summer camp is organizing a hike and needs to buy granola bars for the campers. The granola bars come in small boxes and large boxes. Each small box has 10 granola bars and each large box has 12 granola bars. The camp bought a total of 9 boxes that have 100 granola bars altogether. Write a system of equations that can be used to determine the number of small boxes purchased and the number of large boxes purchased. Define the variables that you use to write the system. All right, so let's go ahead. How about they want us to solve for small boxes and large boxes. So how about let's use S and L. Okay, a lot of the times on the SAT, it's going to blatantly tell you, let S represent the number of small boxes. So and then L is the number of large boxes. All right. So they told us that we have, let's see, each small box has 10 granola bars and each large box has 12 granola bars. All right. And we know that altogether, our total number of granola bars is supposed to be 100. So one equation we could set up is 10 times my number of small boxes plus 12 times my number of large boxes is going to give me 100 granola bars. Because that makes sense, right? However many small boxes I buy times 10 represents the granola bars from the small boxes. However many large boxes I buy times 12 is going to represent how many granola bars come from the large boxes. They told us that in total, we're supposed to have 100. Then they told us that altogether, the total number of boxes themselves is 9. So my number of small boxes plus my number of large boxes should give me 9. All right. This word bank down here, basically when you do this on Delta, there's going to be a word bank for you to put in these spaces here. All right. So that's where that comes from. All right. So let's go ahead and try number 8. It says, Delvin runs a farm stand that sells strawberries and blueberries. Each pound of strawberries sells for $2, and each pound of blueberries sells for $3.50. Delvin sold twice as many pounds of blueberries as pounds of strawberries, and he made $225 altogether. Write a system of equations that could be used to determine the number of pounds of strawberries sold and the number of pounds of blueberries sold. Define the variables that you want to use to write the system. All right. So, let's see. So we're selling strawberries and blueberries. And you want to make sure that you actually look, hey, like what are they asking me to solve for? They want us to determine the pounds of strawberries sold. And they want us to determine the pounds of blueberries sold. All right, so with that in mind, when we pick our variables, that's what we want our variables to represent. So let's say S represents our pounds of strawberries. And B is going to represent our pounds of blueberries. All right. Now, first thing I would look at is the cost information that they gave us, right? They told us that our strawberries sell for $2 and our blueberries sell for $3.50. And then they give us the total amount of money he made, which is $225. So the equation you want to set up here is that 2 times our number of pounds of strawberries plus $3.50 times our number of pounds of blueberries is going to have to give us $225. Next, it says, let's see, he sold twice as many pounds of blueberries as pounds of strawberries. Okay, so I feel like a lot of the times people get confused on like which one they're supposed to multiply by 2, right? So let's just think, if he sold twice as many pounds of blueberries than strawberries, that means he sold more blueberries than strawberries. So let's just say hypothetically he sold 20 pounds of blueberries, right? That means that he sold 10 pounds of strawberries, right? So what we can say here, if we wanted to set up a system of equations here, our number of blueberries would have to be 2 times our number of strawberries, okay? So we could say our number of blueberries equals 2 times our number of strawberries. And this would be our answer here.